We're on the second video for solving word problems. This is section 7.6, and on this one it's agriculture, and we're going to translate this word problem into an equation that we solve. Okay. An empty avocado crate weighs 4.2 kilograms. How many avocados weighing 0.3 kilograms each can be added before the total weight of the crate reaches 15 kilograms? Okay, so let's break this down. Let's go back and say we have an empty avocado crate. The crate weighs 4.2 kilograms. And then it says how many avocados. So notice how many avocados weighing 0.3 kilograms each can be added before the total weight of the crate reaches 15 kilograms. So the total weight of the crate will be 15. And then the avocados weigh 0.3 kilograms each. And then we have to set up our equation based on that. So how many avocados? That was the question. We're going to write that as x equals the number of avocados. So that's our goal right there. Now it says the empty crate weighs 4.2. Each of the avocados is 0.3 kilograms. So we're going to say 4.2 plus the weight of the avocados. Well, the weight of the avocados is going to be 3/10 x, right? So every avocado weighs an average of 3/10 of a pound. And we're going to multiply that times the x. Our total is 15. And then we solve. So setting it up is always the most difficult part of these. If we can get the equation written, then the rest of it's not so bad. So 0.3x equals 10.8. We're going to divide that by 0.3, 3/10. And we find that x equals 36. So that is 36 avocados. All right. And then you can always put that back in. Remember to check 0.3 times 36 and then add that to the 4.2. All right. There's one of them taken care of. Here's the next one. 1/10 of the parts tooled by a machine are rejects. All right, so 1/10 of the parts. Whenever you see of, right, of the parts, that often means to multiply. So 1/10 of the parts tooled by a machine are rejects. So that means that when you make a bunch of parts, 1/10 of them have to be discarded because they aren't what they're supposed to be, right? There's some flaw in them and they're rejects. And then it says how many parts must be tooled to ensure 4,500 acceptable ones. Okay, so we have to end up with this many in the end. Now this one's always kind of setting up one like this is a little bit tricky. Okay, how many parts? So we're going to call that our x. X equals the number of parts. And then let's think about this. 1/10 of the parts are rejects. So that means multiply 1/10 of. We've actually done this in some previous lessons where we translated something that said, you know, like 1/5 of 8 is this, 1/5 of 10, something like that. So that means multiply. We're going to write 1/10 as 0.1. So 0.1x equals rejected, hold on, let's say number of rejected parts. Okay, and our total, the total we need is going to be 4,500 parts. Okay, Now this could be anything, right? But this is common whenever you are manufacturing something, that you're going to have things, parts that have to be rejected, right? That's just part of it. Okay, so what we want to do is, how many parts are we going to have to manufacture? Then we're going to take out the rejected ones, and we're going to end up with 4,500. So it's X. We're going to subtract 1/10 of those parts that we make to end up with 4,500. So that's the equation. Now, that's not too bad, but still sometimes coming up with it is a little bit confusing. This is a 1x, and we're subtracting 0.1, so that leaves me with 0.9, or 9/10. So 9/10 of the parts are going to be good. So 9/10 of that number equals the 4,500. I'm going to divide by 0.9, and I end up with 5,000 parts. So that means that whenever we make them, we have to reject 500 of them, because 1/10. Now that's always approximately, but approximately this many parts have to be rejected. Okay, here's our next one. Now, this one's a little bit longer. This is a construction problem. A total of $1,120,000 is budgeted for constructing a roadway. The rule of thumb for this type of project is that the pavement costs twice the amount of the base material, and the sidewalk costs 1/4 the amount of the pavement. Using these figures, how much should each item cost? Now what you have to do is weed through this and see if you can figure out what to base this on, right? The total is this. Because if we can figure that out, then we can come up with the rest of them. The rule of thumb for this type of project is that the pavement costs twice the amount of the base, and the sidewalk costs 1/4 the amount of the pavement. So from that, I know that we're going to base it on the base material. All right, the cost of that. So B is the cost of the base, right? Base cost. Because then it said the pavement costs twice the amount of the base, right? So that means that the pavement is going to be 2 times the base, and that's the cost for my pavement. And then the last one is the sidewalk cost 1/4 the amount of the pavement. Okay, so that means I have to take 1/4 of the pavement, and that's going to give me my sidewalk cost. So 1/4 of 2 is basically 2 divided by 4. That's going to be 0.5 times B. So that's what we're going to use for the sidewalk. Now it told us that the total is $1,120,000. I have that highlighted up there, so that we're going to add all these together. The base plus the pavement, which is 2 times the base, plus the sidewalk, which is half of the base, equals $1,120,000. And that's our equation. So we add these together. That's a 1 plus 2, 3 plus 0.5, so it's 3.5b equals 1,120,000. And then to solve, we divide. When we divide by 3.5, we find that our base is $320,000. And then we can find the other parts of that, right? So we're going to do the base times 2 to get our pavement. So that's going to be 640,000. And then 1/2, times 1/2 B times 1/2, I guess I should say B. B times 1/2 to get our sidewalk cost, which is $160,000. Now you can check this. If you add up 320 plus 640 plus 160, those are all in thousands, then you end up with 1,120,000. So then you can see that, oh yes, it does work, right? All right. So we have one more equation to write. Okay, trades management. 4 partners in a plumbing business decide to sell the business. Based on their initial investments, Al will receive 5 shares of the selling price, Bob will receive 3 shares, and Cody and Dave excuse me, will receive 2 shares each. If the business sells for $840,000, how much is each share worth? Now, I know it's going to be tempting to just try to start figuring, but the goal of this is to write the equations, and when you take your test, you have to write the equations. So if you fudge on this and just try to set it up, try to figure out answers, that's not what I'm looking for. I want to see, can you write the equation and then go from there? So the 4 partners are going to sell the business, right? And so we are looking for how much each share is worth. So X is going to be the worth of 1 share, right? And then it told us that wait a minute, not Bob, Al will receive 5 shares. So Al gets 5 times X. That's Al's. And then Bob gets 3 shares, so 3 times X. And last we have Cody and Dave, and they get the same amount, and that's 2 shares, so 2X for Cody, and then 2X for Dave. Altogether, right, it's $840,000. So once again, this is an addition problem. We're going to take 5X plus 3X plus 2X plus 2X equals 840,000. We basically just add those all up and we get 12X equals $840,000. To solve, we divide by 12. So 1 share, right? Remember, that's the amount of 1 share, is $70,000. Right? So that's how much 1 share is worth. And it asks us how much is 1 share worth. It didn't ask us this time to figure out how much each one of them got, but it would be easy, right? So 5 times 70,000 for Al, so he's going to get 350,000 and so on. But we get to stop with just the worth of the 1 share. Okay, so I'm going to stop this video and then we'll go on to section 7.8, which is about scientific notation.